So today I decided to start to design a rocket, and I didn't really know where to start, so that's basically what this video is. This video is where I started, and because I'm only a high school student in high school physics, I don't really have a big understanding. But subscribe if you want to see more content like this, and hope you enjoy the video. And by the way, I'm talking about real rockets, and not about video game ones. My hybrid propulsion system will work by using a thermal reactor and drive to thrust me out of the Earth's atmosphere and into a station. And in that station, what I'll do is I'll switch out the thermal reactor using a modulated system and a robotic arm for an ion drive. And this is definitely easier said than done, probably. But yeah, that's what I'll do. And the ion drive will be used to fly in space and in low density atmospheres. Because, yeah. How far have I come? Well, anyway. Designing a rocket. Yeah. So I did this thermal ion engine hybrid where it's not actually two of them connected. Obviously not, because that doesn't make much sense. But it's a modulated system where you can switch it out, which is obviously easier said than done. Here's why. So, gravity accelerates at negative 9.8 meters per second squared. Well, negative or just positive in the downwards direction. But yeah, so a rocket would have to go faster, would have to accelerate faster than 9.8 meters per second squared to get out of the atmosphere, right? And that's just ignoring air resistance. But yeah. So you have to look at an ion engine. How much thrust or acceleration does an ion engine create? And possesses thrust of 25 to 250 millinewtons. A millinewton is 1,000th of a newton. Yeah, so that's not gonna get out of the Earth's atmosphere. And I think if we go down here, so basically ion engines don't create enough thrust to get out of Earth's atmosphere because it can't beat gravity. But that's not the only issue. Also, another issue with ion thrusters is they don't work in Earth's atmosphere because there's ions everywhere, in the air too. So this propulsion right here, other ions from outside are going to get in and react with these ones, creating less thrust or no thrust at all. We can just use a thermal nuclear thruster. And let's see if they have another cool diagram here. Yeah, I think this one works fine. What happens is these nuclear rods right here create lots of heat. And what happens is they then pump hydrogen or other gases, just depending on which one they want to use, around the heat, basically, around the nuclear rods. And what then happens is it superheats and gets compressed out of the engine, creating thrust. And that creates a lot of thrust, actually. And obviously it's kind of dangerous because if that was to blow up, it would release radioactive matter all over the Earth, or yeah, pretty much all over the Earth, because of winds and stuff. So what happens is in nuclear fusion, usually if it blows up, it's not radioactive because it has like time to slow down. I don't really get it yet, but so yeah, when it starts to melt down or like shut down, the reaction stops, which the reaction that creates radioactive material stops. So if it blows up, no radioactive material is being spread, so it's a lot safer. And yeah, basically the thrust from these nuclear thermal rockets is enough to get out of Earth's atmosphere. And it's actually better than most chemical ones. It has like triple the thrust of a normal chemical one. So yeah, that's why I'm using a thermal hybrid nuclear fusion thermal reactor and a ion reactor. Well, I developed a list, a pros and cons list for thermal and ion, whatever they're called, thrusters. And I said thermal, one of its pros was a higher thrust or specific impulse, which is true, yeah. And also another pro is it can reach 10 to 15 kilometers a second, not meters per second. And then for ion, they're very efficient. They have like 90% efficiency, whereas a thermal one's like 60% or something, and a normal chemical one's 35%. Ion also reach 50 to actually it's 20 to 50 kilometers per second, and uses electricity, so it's pretty clean. And the cons of thermal thrusters is they're not too efficient. They use hydrogen. I don't know how that's a con though. That's not a con. Yeah. It's a pro, because when you use hydrogen, you can basically hydrogen it's really abundant in the universe, so you can basically get it anywhere you are in the universe. If you mix it with oxygen or combine it with oxygen, it makes water. And if you have water, you can split it apart and get oxygen for your ship as well as a fuel for your ship. So yeah, it's a very good fuel, and it's super light. And then it has a high amount of pollution, which is mostly just hydrogen and some nuclear waste, but that's like barely any, and you can get rid of that easily by just burying it underground. And also with nuclear fusion, I'm not even sure if there's nuclear waste or much at all. And then for ion drive, one of the cons is small specific impulse. It's like, we already went over this, it has like 20 Newton meters, millinewtons per second, or constantly. It doesn't work in Earth, and it's pretty slow acceleration. So basically, that's why we use the ion ones in space, especially if it's reaching speeds up to 50 kilometers per second, and this is only reaching 15 kilometers per second. You can have constant electricity. Constant flow of acceleration and deacceleration. Whereas this, you can run out of fuel, except for if you find a way to harvest hydrogen in space, because there's still particles in space. So that's why thermal is better for getting out of atmospheres such as Earth, and ion is better for flying in space. And that's why my hybrid system. I hope you enjoyed this video, and subscribe and like the video if you did, and leave a comment if you have suggestions or tips.